So this video I'll be solving the second practice quiz on curve sketching. Hopefully this will help you out with the real quiz. Again, it's exactly the same with a polynomial, just doing the same steps but different numbers, and hopefully it'll help with getting all the stuff down. Okay, so again, finding critical points means where the derivative is 0 or where the derivative does not exist, like it's infinite. Since we're not dividing by anything here, we're not only dividing by zeros, there probably won't be an infinite derivative. So basically figuring out where the derivative is 0 and then figuring out if it's a local min or max, which means where the derivative goes from positive to negative or from negative to positive, or the second derivative is greater than 0 or less than 0. Either option. I like the second derivative way. Okay, so let's take the derivative. So let's see, y prime would be 6x squared minus 6x minus 1, and we set that equal to 0. We want to know when that's 0, and it looks like we're going to have to use the quadratic formula here. So x is equal to negative b, that would be positive 6, plus or minus the square root of negative 6 squared, which is 36, minus 4. A is 6, c is negative 1, all over 2a, which is 12, since a is 6. So let's see, 36 plus, because it's minus and negative, so 36 plus 4 times 6 is 24, 60. And 6 over 12 is 1/2, so that's 1/2 plus or minus the square root of 60 divided by 12. Okay, let's take those numbers. 60 square root divided by 12 is 0.645. So that's 1/2 plus or minus 0.645. So plus 0.5. So I get 1.145, or 0.5 minus 0.645, or negative 1.14, negative 0.145, negative 0.145. Those are two x values. So those are either going to be maximum or minimums. And we want to find the y value so we can plot it, so we can put the dots in the thing. So, and we also want to find if there are maximums. Let's figure out the y values first. So you just got to plug those back into there, which is kind of a pain. And if we do that, we should get that the first one is 0.076. So we have negative 0.145, and the y value is 0.076. Again, plugging that back into 2x cubed minus 2x squared minus x, kind of a pain. And then the other point, if it's 1.145, plug that back into there, and the y value is negative 2.076. Okay, those are 2 points. Now we gotta know if they're max or min, so we take the second derivative. So the second derivative, and again, we don't have to. We can plug in numbers on either side into the first derivative formula and see if we get if it goes from positive to negative. Again, if it goes from positive to negative slope, then we know that it's a max. And if it goes from a negative to positive slope, we know it's a min. Or we take the second derivative. The second derivative is going from positive to negative. So the second derivative is less than 0. It's changing in a negative way from positive to negative. Here this slope is changing from negative to positive, so the second derivative is greater than 0. And so that's what I'm going to do. I'll do the second derivative one because it's easy here. Okay, so derivative of 6x squared, that's 12x minus 6. Alright, that's a real easy second derivative. And let's see, so the second derivative at negative 0.145 is 12 times negative that minus 6, which is negative 7.74. So we know that that is Since it's less than 0, it's negative. We know it's a max. So 145 is a max. And then we can guess the other one has to be a minimum, but we can prove it. Plug in 1.145. So 12 times 1.145 is going to be bigger than 12. Minus 6 is clearly going to be positive. I'll do it just for the heck of it. Minus 6. I get, oh wow. Yeah, well, it makes sense. 7.74. And we know that that's a minimum. Okay, so now we're done. We found the critical points. Anywhere where the derivative is 0 doesn't exist. And we determine if they're local max or local min. So this one here, let's just label it. This one here is a max. The negative one is a max. And this one is a min. And so this is kind of our answer here. Alright, now find the other local extreme, which means the endpoints. So I said the endpoints are negative 1 and 1.6, so you plug in negative 1. So what is the value at negative 1? So y at negative 1 is 2 times negative 1 cubed minus 3 times negative 1 squared minus negative 1. You got to be super careful with negatives and stuff. Negative 1 cubed is negative 1, so it's negative 2. Negative 1 squared is positive 1, so minus 3, so minus negative plus 1. Negative 2, see that's negative 2, so that's negative 4, right? So negative 4. So we have another point, which is x equals negative 1, y is negative 4. And the other endpoint, y at 1.6 is 2 times 1.6 to the third power minus 3 times 1.6 squared minus 1.6. This is definitely a calculator problem. 1.6 cubed times 2. I get 8.192 minus 1.6 squared times 3 minus 7.68 minus 1.6, and what is that? Minus 1.6 plus 8.192. I get negative 1.088. So our other endpoint is 1.6 comma negative 1.088. And I'm going to circle those so I can find them easier. Alright, now, what is a global? Out of all these, we have 4 points. In the interval, we care about what is the biggest value. Y value, right? That's what's the biggest Y value here. So let's see, here we have let's see, positive. There's only one positive one, right? Which is this one, 0.076. They're all negative. Okay, so the biggest one, so the global max would be negative 0.145, 0.076, and the global min, what is the most negative one? Let's see, here we go to negative 2, here we go to negative 4, here we go negative 1, so this is the winner. So negative 1 comma negative 4, that's the furthest down. So again, this helps us graph it. We know that, okay, we got to go as high as barely above the x-axis, but we got to go all the way down to negative 4. And we know the x value goes from negative 1 to 1.6, so we already know how far to go left and right on our axis, but now we know we got to go down to y equals negative 4, but not very high. Okay, so let's do the next page. So find the x-coordinates of all inflection points. That's where this switches over from concave up to concave down, which is typically where the second derivative is equal to 0. So we already said the second derivative is 12x minus 6, where that's equal to 0, so that's 12x is equal to 6, so x is equal to 6/12, which is 1/2. So that's the only one. That's kind of nice. So 1/2 is the inflection point. There's one inflection point there, which makes sense. There's one max and one min, and which means there's an inflection point in between them. Now I find it easier to just start graphing now, because these will be obvious once we look at the graph. You can figure this out by, okay, here's the inflection point, here's a max, here's a min. But these, there's really no math in these. You just look at the graph or look at the points we already made. So we don't really have to do any more math for these. So let's graph it. So let's see, we want to go all the way from -1 to 1.6, but all the way down to -4. So let's put -4 way down here. So here's -4. So that would be -2. So our 1s are only about that big. And we know we don't have to go up very far. So here's -1. And that's as far as we go in the x direction. And then we go to 1.6. So here's 1. And here's 2, so 1.6 would be a little more than 1.5, something like that. Okay, so we put our points on, so we have a -1, -4. So my, of course, it always runs right into my number I write down. I don't know why that always happens. So -4, so that's about right here. That's the lowest it gets. That's one of the boundaries. And then we have a -1.145, 0.076, so just a little bit here and just barely above, so like right here. That's our maximum. And then we have the other boundary is 1.6, -1.088, so here's -1, so it's practically just below that. And then 1.145, -2, so something like this. Okay, and we know that's a max, that's a min, goes back up, so it's going to look something like this. Goes up, comes down, goes up, and it keeps going, but we only care about to right there. Of course it keeps going, and here it keeps going, but we only care about to right there. Okay, that's what our graph should look like. And again, you can check it on Desmos. It should look pretty much just like that in the area that we care about. And the last thing is the inflection point. So at 1/2, right here, there's an inflection point, so right about there, which makes sense. It's where it switches over from getting steeper and steeper to less and less steep. The inflection point should always make sense, so you did something wrong. And then this is obviously concave down. This part's concave up. Concave down forever, because this just keeps going straight down. This is concave up forever. So I asked here, okay, where is it concave down? So it's always from inflection point and to the end point, right? That's all we care about. So we would say from the inflection point is 1/2. So from 1/2 to the right end point, which is 1.6. And where is it increasing? Where is it positive? The slope positive. So from here to here, which is -1. So -1 to, what's the maximum point there? -0.145. -0.145. That's one part of it, from -1 to -1 from here to here, and then from here to here, which is the other from the minimum to the end point, which is 1.145 to that end point, which is 1.6. Those are the places where the slope is positive. If I had said where it's negative, it would have been just one place, so it would have been a little bit easier. Okay, that's the first one. And again, check on Desmos. You should be able to draw a graph that looks exactly like what you see on Desmos. It's pretty cool without plotting points. Okay, now the trickier ones. Let's do this one. The sine, cosine ones. Okay, so again, take the derivative, set it equal to 0. So y prime is derivative of 2x is of course 2. Derivative of that, derivative of cosine is negative sine, so we know it's going to be a positive. And we get when we do the product rule, the chain rule, we're going to get a 4 because it's cosine 4x, so it's times 4. So I know I'm going to get a 4 times 3, which is going to be a 12. So it's plus 12 sine of 4x. And that's right, yeah, so I'd take a 4 out, times 3 is 12, and it's plus because the cosine is negative. Okay, that's the derivative. We set that equal to 0. Let's see, so therefore sine 12 sine of 4x is equal to -2, or sine of 4x is equal to -2/12, which is -1/6. Okay, so when is the sine of 4x equal to negative 1/6? So I'm going to draw my unit circle here just to see what we're thinking about. Sine is the y value, so negative 1/6 is not down very far, right? Here's negative 1, here's negative 1/2, it's 1/3, so 1/6 is half of, that's negative 1/2. It's just right about here, right? So we have this point and this point are where the y value is negative 1/6. So those are 2 points where sine of 4x is negative 1/6. Okay, so what are those points? And so you take the inverse sine. So okay, so we have basically from here to here, we have this is one answer, and then we go all the way around, so all the way around to here is one answer. So when we do the calculator, the inverse sine, we're going to get this little thing here, that little short one, and then we have to figure out the big one. It'll only give us one answer, and we have to always figure out this, what they call the symmetry solution, like we did in pre-calc. So I'm going to do inverse sine of negative 1/6, so 1 divided by 6, negative goes inverse sine, and I get 0.16744. This is terrible, it doesn't get small very fast. Okay, so 4x then is equal to negative 0.16748. Let's say 45 and keep lots of decimal places. Okay, that's what 4x is equal to. Plus, of course, we can go 2 pi around. Right, we can go, that's this one here, that's the negative one, so it's right here, right? So it's a negative answer, and this of course is going to be in radians. Make sure your calculator's in radian mode. So that's this one. And then we know we can add 2 pi to it, add 2 pi to it forever, so we can say plus multiples of 2 pi, because we can go 2 pi, and it can be negative, right? We can go 2 pi backwards. Okay, that's one solution we have. Now we can divide all that by 4. So x then is equal to that divided by 4. So negative 0.041. I'm going to round off a little bit. Negative 0.0419 is close enough. Plus divide that by 4 and I get pi over 2 times n. Multiples of pi over 2. Okay, that's one of our solutions. The other one is this angle here, which is pi plus that. Okay, so the other solution is 4x can be pi, because this is 180 degrees is pi plus that little bit. We know that little bit is this. So why am I writing 4? Is pi plus 0.16745 plus 2 pi n. Because again, we can go around and around the circle, forwards or backwards. Okay, so what's that equal to? Pi plus that 0.16, so pi plus 0.16745. I get about 3.31. So 4x then is equal to 3.31 plus 2 pi n, or x is equal to, divide that by 4, 0.827. 0.827 plus, divide this by 4 again, pi over 2 times n. Okay, now we got to figure out which of those fit in between 0.4 and 1.8. Well, 0.827 does, so n equals 0 does, and pi over 2, let's figure out what pi over 2 is, because it's 1.57, right, half of 3.14. So this is 1.57, so I'm going to rewrite that a number we can make more sense of. 0.827 plus 1.57n. Okay, 0.827 works. If we add 1.57, that's definitely too big. That's bigger than 1.8. If we take away 1.57, that might work. Let's figure that out. 0.827 minus 1.57. That gives us negative 0.743. That doesn't work. That's too negative. We only go to 0.4. Right? We're only going as low as 0.4. If we take away 1.57 from this, it gets negative. So that's not going to work. So this one gives us 0.827. That's one of our x values. Then let's figure out this one up here. Negative 0.0419, that doesn't work because we only go from 0.4 to 1.8. But so we know we have to add something, so let's add pi over 2. Let's add 1.57 to that. So 0.0419 negative plus 1.57 gives 1.5281. That works because it's within 1.8. So this gives us x is equal to 1.5281. The next one's going to be another pi over 2, another 1.57, which is clearly too big. That's going to give us past 1.8. That's going to give us 3 point something. So this is our only one here. Now let's figure out the y value. When x is equal to that, y is equal to, we got to plug that back into our equation, which is kind of a pain. 2 times that minus 3 cosine of all that. So that's kind of a lot of calculator work. So let's do that. And if I do that, I'm going to get that. That one up there is going to be see, for 0.827 it's going to be 4.613. Y is 4.613. I'm going to do this, so that's my point. And then when x is 1.5, and I'm looking at Desmos to do this because it's a lot easier. When x is 1.5, I get that the point is 0.1. So y is 0.1. So our point here is 1.5281, comma 0.1. Okay, those are our points. So I'm going to circle those. And we got to figure out next if they're max or mins, which is... Okay, so now how do we use calculus to figure out if they're max or mins? So let's see. We have to take the second derivative set equal to 0, which isn't so bad because the first derivative is just this, so that's going to be 0. So take the second derivative, we're just taking derivative of that. So let's do that. It's not so bad. So we already figured out that the first derivative was 2 plus 12 sine of 4x. The second derivative then is going to be, that's going to be 0. So this is positive, and we're going to get another 4 out of this with the chain rule. So it's going to be 4 times that, so it's 48 cosine of 4x, and derivative sine is positive cosine. That's good. The 48 doesn't matter. We want to know if it's positive or negative. So we're multiplying by positive numbers. So we just got to have cosine of 4 times those numbers are positive or negative. So y double prime at 0.827, make sure your calculator's in radians, equals 48 cosine of 4 times 0.827. So let's do that. So 4 times 0.827 cosine. I get that's negative. So clearly times 48 is negative. I'll do that anyway, but I don't have to. Negative 47.3. So that means it must be a max. So, and then the other one has to be a minimum, but we'll try it anyway. So y double prime at 1.5281 is 48 cosine of that. Cosine of 4 times 1.5281. Okay, so put all that in my calculator. 4 times 1.5281. And that's positive, which we knew it had to be, so that's good. So 40, that's positive 7 point. Must be a reason why we should have known that. Positive 47.3. So it is clearly the minimum. So it's nice to label these. So 1.5 is a min. So this is a min, and this one over here is a max. It's going to be a peak. Okay. Now we do the endpoints. So it's just calculator work. Plug in the n values into here and make sure we use radians. So one of them is So y at 0.4, y at 0.4 is 2 times 0.4 minus 3 cosine of 4 times 0.4. Show your calculators in radians. That's obviously 0.8 minus, okay, 4 times 4 cosine times 3 plus 0.8. I get 0.71. Oh, for this whole thing, yeah, I did the whole thing in my calculator. I get 0.71. And then y of 1.8. Again, more calculator work, plug 1.8 into our equation. So that would be 2 times 1.8 minus 3 cosine of 4 times 1.8. And we do all that in our calculators. We get, see, 4 times 1.8 cosine times 3 negative plus, I get 1.77. So our points are 0.4, 0.71. That's what 1 in point is. When it's 0.4, it's 1.71. And that's not what Desmos is telling me, so I must have done something wrong. So how about the other one? When it's 1.8, it's 1.77. So 1.8, it's 1.77. That one is right. So okay, what did I do in my math here? So let me check that again. So maybe I should have written this out. Don't do too much in your head. Or yeah. Okay, so let me try that again. So 4 times 0.4 equals that cosine times 3 negative plus 0.8. Okay, I did do that wrong. Somehow I plugged in my calculator wrong, so it should be about 0.888, not 0.71. So check with Desmos like on the quiz when you're doing this, because it's super easy to make a mistake. 0.888. So the point is that, so times 0.888. Okay, that's better. So those are our 2 points. Those are 2 endpoints right here. Now we do, okay, which is the biggest? So let's see, biggest y value. Here we have a 4.6. Here we have a 0.1. 4.6, looks like the 4.6 is the biggest. So the maximum on our interval is going to be 0.827 and 4.613. That's our biggest. And the minimum one, let's see, 0.888 is pretty small. 0.1, so the 0.11 looks like it wins. So that's going to be 1.5281 to 0.1. So when we graph this, we got to go as high as 4 in the y-axis, a little over 4, about 5, because it's almost over 4.5. And we don't even have to go below 0. So I always just gave you axes, so we don't even need it, because our y value never gets below 0. The smallest it's going to be is 0.1. Okay, getting there. Okay, inflection points. Second derivative is equal to 0. So we took the second derivative already. So the second derivative is 48 cosine of 4x. We set that equal to 0. The 48 doesn't matter. Divide both sides by 48. So it's basically when cosine of 4x is equal to 0. So we draw our unit circle to figure out what's going on here. So when is cosine equal to 0? Cosine is the x value, right? Cosine is the x value. So the x value is 0 right here, and right here. So that's when what's in the parentheses then, cosine of pi over 2 and 3 pi over 2. So basically that's pi over 2 plus pi and another pi and another pi and another pi. So plus pi n plus multiples of pi. That covers both of them in this case. So when you get nice simple ones with 0, they often cover both. So here we start with pi over 2, and then we can just add pi's, and as we go around, because remember pi is 180 degrees. Or we could subtract them, right? Same way, n can be negative. So 4x then has to be equal to pi over 2 plus pi times n, divide both sides by 4. X is equal to pi over 8 plus pi over 4n. Let's give us some numbers there so it's easier to kind of figure out what's going on. So pi divided by 8 is 0.3926, say 0.393. So x is equal to 0.393 plus pi over 4 is 0.785 plus 0.785 n. We want to be in between 0.4 and 1.8. Let me write that down here. 0.4 and 1.8. Let's see, 0.393 doesn't cut it, right? So we got to add 0.785 or n equal 1 solution. That's going to work. So we'll do that. What's that one? So 0.393. And I get 1.178. So 1.178 works. That's 0.393 plus 0.785. If we add, let me check that again. Yep, that's right. So how about if we add another 0.785 to that? Well, that will clearly not work because that'll be bigger than 1.8 because 0.7 plus 1.1 is 1.8 is 0.785. So this is our only one. So our only inflection point in this interval is x equal 1.178. Okay, now I think it's easier to graph it right away, again, rather than doing these. So our 4 interesting points are the endpoints. Let's see, we already know the maximum goes to 4.6. We better put a 5 up here. And we don't even need to go below 0, but oh well. And that means that, and we only go from 0.4 to 1.8, so we don't have anything over here, so it starts at 0.4. If that's 5, let's see, how can I break up this into 5? This would be 2.5, so this would be about 2 here. See if I did that okay. Yeah, that's pretty good. And then that means that our numbers here are going to be not very well spaced. Oh well. This is 1, 2, 3, 4. So 4, 3, 2, 1. Okay, let's plot our points now. We have a 0.4. The furthest over, it's 0.888. So 0.4 is a little less here. It's 0.888, so something like that. And then at 1.8, it's the other endpoint. 1.8, which is right here, it's like 1.77, so that's somewhere around there. And again, that's our interval, so it's really small. Oh well. So here's where we're worried about. There's our interval we're worried about. And the other ones better be in between. So at 0.827, it's 4.613. So 0.827, it's way up here. That's our max. And the minimum is at 1.5281.1. About 1.5, it's 0.1, so way down here. Okay. So it's going to be tricky to draw. So it goes up, goes like that, goes up, maximum, down to a minimum, and then goes back up. And that's what it should look like in that interval. Of course, it keeps going, but we only care about from those points. And the inflection point should be right around here, right about halfway. Let's check. So 1.178, little over 1, right, a little over 1. So we go up here. So yeah, just about perfect. Where it switches over from concave down to concave up is right there, the inflection point, and it's right about where it should be, 1.1, about halfway between the. It doesn't have to be halfway between, but it's usually around halfway in between the peak and the valley there. All right, now where is it concave up? Concave up is here, so from the inflection point to the end point. The inflection point is 1.178, so you go 1.178. And the end point was 1.8, right? So up from here to here. And then where is it decreasing? Where is the slope negative? So it's negative from here, the peak, to the minimum, from the max to the min. So that's from 0.827 was the max, that's this one, and the minimum we figured out was 1.5281. So that's where it's decreasing. Only one interval where it's negative in the area we're talking about. Okay, hopefully you could follow all that. Ask if you have any questions, and good luck on the quiz.